Hello and welcome back to another video. A lot of you will already know this, but Bevy 0.9 dropped on the 12th of November, and I'm a few days late uploading this because I haven't had time to actually have the video recorded, but hopefully I will get that done now. So this is a big update, like a lot of the updates have been since they have moved to a 3-month cycle of updates. But also, like, not a particularly intrusive update. If you were using or wanted these features, it's incredible. But otherwise, you're either just going to get a huge performance boost or not. Like, it's really depends on where you're using it. It's a much more narrow, whereas a lot of the other updates have been, like, pure, like, these features are required. But let's get straight into it. They've added HDR post-processing, tone mapping, and Bloom. So there's now a Bloom post-processing that you can get, which looks pretty incredible, but again, like if you're not using Bloom, this means nothing to you. But it does come with the HDR improvements for it now renders all textures as high definition, like high dynamic range textures, and only turns them into low dynamic range before rendering them. So if your shader needs access to this high dynamic range, such as what the Bloom does, you can actually access that now without needing to, as opposed to what Bevy used to do, where it would, after each step of the shader, remove all the dynamic range, so you would lose it. And this is enabled by turning HDR on the specific camera. They added fast approximate anti-aliasing, which is just, again, like an alternative if you're already using anti-aliasing. This is a faster version that uses an algorithm to detect edges in the color rather than using the actual mesh to detect edges. This has some pros and cons that it's listed down here, such as the FXAA, which it already has by default, is crisp and higher quality with edge detection on the actual geometry, which leaves things like shadows and textures un-anti-aliased. But the FXAA enables you to use a blurring effect which includes on the textures and the shadows, which is faster and cheaper. And in some cases, you might want your textures. As you can see up here, they have the box. It actually anti-aliases the textures as well as the edges of the shape. They've also added the Deband Dithering, which is really hard to see. They didn't pick a particularly good image for it. But if you look at this, you can see there's a faint like echoing line through the ground plane here. As the light steps away in distinct intervals, it decreases. This just adds dithering between so that it's much harder to notice. In theory, the effect is still there. It still steps down, but it dithers between the colors so that you can't notice it as easily. And this is enabled by tone map on the camera bundle. Post-processing view now targets double buffering. This is that Bevy used to have a double buffering method that didn't actually have two buffers. You would output the result from your shader into a buffer that was then copied into the main buffer. Now it uses a view target that when you call the access to it, it will return you a source and a destination buffer, and Bevy will flip back and forth between which is which after each shader does its effects. This saves a lot of performance in rendering, but again, if you're not using shaders, this doesn't have a particular impact on your Bevy application. Now that Bevy's added these other new things with shaders, they've also implemented the texture rendered targeting texture format handling. Whoa, that's complicated. And this is just more that Bevy will now dynamically decide which texture, as opposed to at compile time, what texture format to use, meaning that people that are using more customized Linux distros and things like that will result in actually using the correct texture thing, and also means that textures internally to Bevy can use more standardized formats. Like they say here, they use RGB 16 floats for their HDR textures, whereas before they couldn't do that because they needed to use the standard one that was for each platform. Now it's just rendered to the platform-specific thing at the end of the rendering path. And they have an example here of you can render, say, just to the red channel. This is something that's near dear to my heart because I've been working on the scene videos, and I was about to get to making the video about editing the scenes, and that's the new scene format. Amazingly, they've managed to strip out all the complexity in that they used to have really long file paths and things like that, that now it all boils down to an actual human readable format that doesn't have miles of strings and is all shrunk down nicely. This will hopefully become very useful for people that use scenes and actually want to write them by hand. It's also significantly smaller to store and save, and they've extended it so that it has an entity section which will allow for assets in the future to be stored inside of scenes as well. This is what the new scenes look like, where they have a map of like a 0 entity and then, you know, components and all that. Whereas the old version was a horrible monstrosity of nested strings, and you could have duplicate entities because it was storing the entity 0 and its components, and then entity 1 and its components. Now it simply stores a keyed version, so it's 0 and its components, so you can't have duplicates anymore. Talk about the simple syntax, and they've removed all the serialization. They've got nicer enums, and this will come up later as when they've improved reflect, and then the top level struct that I was talking about, and making it a map. You can also now export scenes into a binary format, which says here you can get almost 5 times smaller compression ratio because you don't have to self-describe the scenes anymore, which again, if you're trying to make scenes, very incredibly useful. For a lot of people, not that much of an impact. Made a dynamic scene builder. Again, if you've been watching my Bevy Basics series, I've just talked about making one of these yourself, where it's a system that takes in the entity iterator and will only serialize the entities you provide. You can now call dynamic scene builder from world and then tell it to extract specific entities by iterating over entity lists. Any entity iterator will work, and then you call build and it'll actually make the scene. This does make my previous video a little bit redundant, but it is now in base Bevy, which is, you know, an improvement. They've got more scene construction tools in that you can now clone scenes by giving it a type registry. It'll clone all of the components that are reflectable. And you can also now convert a dynamic scene into a scene. And this is useful for, say, if you want to have some kind of system that spawns in scenes, but you have to load some of those scenes from file and other scenes that you actually generate dynamically at runtime. The loading from file ones will have to be dynamic scenes because it's the only way to load from a file, but you can now convert them into normal scenes and store them as in the same like vector or hash table that you were storing your at runtime created scenes. They've improved the entity component API in that they have changed bundles to being everything. All components are now self-contained bundles, meaning that when you create a bundle, you no longer need to derive, like you still derive bundle on the struct, but you no longer need to declare bundles beforehand. Like if you, in this example, were to have a transform bundle inside this bundle, as you want to expand the transforms, you would then need to put a hash metadata bundle tag above it. You no longer need to do this because it now considers all components to be bundles. And when you insert things, you just wrap single components and bundles together in a tuple to insert in one iteration. This will be seen here. So originally you would spawn and then insert, or you would spawn a bundle. Now you can just spawn and give that bundle. And the same goes for components, where before you would spawn and insert a component, now you can just spawn with that component, immediately ripping out a lot of boilerplate, which will be incredibly useful. This is one of the few things that applies to just about everyone using Bevy. And the same thing applies here, is instead of calling chains of inserts, you now wrap them in a tuple and insert them as a single bundle. This incredibly improves Bevy's performance under the hood because it doesn't need to make archetypes for every individual component as you insert them, because it knows that they're all being inserted at once, that they will be moved to that archetype. And this also applies for removing bundles in the same way. Instead of chaining removals, you can remove them all in a single pass. Exclusive systems, reworked so that now instead of having exclusive systems need to be tagged as exclusive, they are just treated as normal systems. Bevy claims that this is because they're moving towards a different scheduler, which will hopefully be able to determine what exclusive systems are using what parts of the world, and therefore schedule exclusive systems to run in parallel while still giving you full world access to the system. This also means that you no longer need to store state in your system by like using system states and then extracting it from the world. Instead, you can now pass that system state in as a parameter, and Bevy systems will take care of that in the exclusive system, which is another great reason to move away from the exclusive systems being explicitly declared, because this required them to only be able to take in a mutable world. Now they can do basically what any other Bevy system does, which is dynamically determine what functions to take in, such as query states can also be passed in instead of being derived at the time of running the system, and also gives you access to local resource. So instead of having to insert a resource into the world to hold your system's local state, you can now use local like you would in any other system. Bevy now uses GATs, which, again, unless you're actively digging around in that area of Bevy, doesn't really make that much of a difference. It just means that they got to remove the sort of pseudo trait that they'd implemented to get around, they say here, the world query GATs, a lack of real GATs hack trait, and fetch, and it's all been compiled down into the world query instead, which, if you're using that, phenomenally useful. For most general users, not that good, but you should expect your plugins to now, like people making plugins should have a great time with that. You now need to derive resource, which is something that they implemented with components in 0.7 or 0.6, no, 0.7 or 0.8, but basically the last one before that. And it basically just means that you need to actively declare a component as being you have to actively declare a struct as being a resource. This will allow you to basically prevent conflicts, because you can't use things like just a vector of a type anymore, because that would have the orphan rule of you can't derive resource on something that you didn't implement, so you need to use new types, meaning that a system can't, or a plugin can't, like behind the scenes, be using a resource that you are then overriding. You have to explicitly declare that a struct is to be used as a resource. This will in some cases have resources that are declared, or structs declared as both resources and components, if for some reason you insert them in both places. It also means that they can implement other things in the future that are related to resources getting derived values and stuff. They've changed the ambiguous API, so instead of having ambiguous sets that you add things to, instead they've simplified it to just declaring that A and B are ambiguous to each other, and I'm assuming this will continue on in that if you make something ambiguous to B, if A and B are ambiguous, then B and C have to also be ambiguous. Like if, yeah, the same as, you know, equals statements, whereas like if A and B are equal and B and C are equal, then A and C are equal. So same thing with ambiguous, I believe. This basically extends the systems traits labels. So system labels being able to be applied. So A and B both are foo, and then you can say that B is ambiguous with all foo. The ECS got optimized is one of those things where, again, you probably won't notice it, but like unless you were in the reads, but it's just a general improvement to just about everyone's things, getting many maps, all just improved significantly in performance-wise. Change detection bypass. This is great for anyone who wants to implement some kind of system that may want to mutably change something without triggering the change detection. For example, if you had a value that comes in set by the user, but you then immediately change it to a different value, say you are using some kind of rotation that's fed in as an integer, but you actually want it to be multiplied by some scale factor, you can use the bypass change detection so that your own changes don't get the update applied. And also for something like the Bevy editor please, its systems all get mutable access and need to access the underlying traits, so therefore trigger the change detection even though you haven't actively changed the component. just viewing the value will change it. Or I guess giving access to the value as being viewable, as being changeable, changes it. So this would allow them to, say, have the bypass change detection to give you immutable access to the transform and then only update it if you actually change the value. Enums can now be reflected, which is a huge improvement. Technically, they were reflectable before, but you were reflecting the value and then using serialize and deserialize to extract the actual underlying type from it. Now, Bevy just actually implements reflect, which, as you can see here, significantly cuts down on the boilerplate required to serialize or reflect an enum. Yeah, you can see no more magic conversions there. Bevy Reflect has also been improved, allowing for reflection of containers and basically allowing you to drain one into another. It just adds more like list functionality to reflected types. And apparently it lets you turn one reflected type into the more generic reflected type. So you can now reflect a struct, an enum, or a list into a dynamic reflect. Whereas usually you were going the other way. You were taking a dynamic reflect and casting into or downcasting into a specific type. The array in the reflect path API can now use list syntax, which I guess is this, the bar, get index 1, which is incredibly useful, again, if you're using reflect. I have used reflect in my own personal projects, but I haven't got to the point of actually using the path stuff like this, but it seems useful. They have added a new example of the Gamepad viewer, which I guess is useful if you're using gamepads to be able to see what buttons and things are being pressed and what relates to what on the gamepad, which for someone who doesn't actually use a gamepad like myself would be quite useful if I was trying to debug a game and go like, well, what does this button actually correlate to in terms of in-game? Or like in Bevy, what is this button called? That kind of thing. Axes buttons have been changed to take validation functions instead of just allowing you to set the value. You now have to provide the release threshold, and this will mean that it will return an error, or I believe it just returns an error. I don't think it panics if you do something like set the release value lower than the press value and therefore like an invalid state. It will not let you do this anymore, whereas before it would because you were just setting the value yourself. This will now have checks in place preventing you from setting in irrational values. They've added a ScanCode input, which works exactly the same as the keyboard keycode inputs, except using ScanCodes. So in their example here, they've said ScanCode press 33, which is the physical key position of the F, which is like in 5 up 3 is the ScanCode 33. Whereas the key code pressed F is specifically wherever your keyboard binding F is. So if you're on a non-English speaking keyboard, the F key may not be in the same place. Time shaded globals means that you can now access the time function in your shader, and it will be universal between all shaders what the time provided is. This will be good for if you need to run animation-based shaders, such as this one, where the cube changes color over time. They've changed the high entity render slowdown optimization, as this section is called. This is to do with the way Bevy renders things is it pulls the renderable objects out of the world and puts them into a separate render world, as in between the main world and the render world. But this resulted in a lot of entity deletion and insertion, and this really slowed things down. So they've optimized this so that when doing, say, 5 million entities, it would take 360 milliseconds. Now only takes 120 milliseconds. Now this is specifically for the insertion and removal of entities. So it's still, if you have a lot of data to transfer, is slow, but does mean that the entity section is about 3 times faster. So you can have a lot more entities before that specific fact starts to slow you down, which is useful for things like GLTF, where it does a lot of sort of unnecessary entity insertions, where a lot of the information could be on a single entity, but is instead in a hierarchical entity structure. This allows you to have more entities without slowing down as much. The Vertex attributes are now fully optional. This means that you could, in theory, have a Vertex attributes of nothing, but is more about like you can say if you don't have normals in your mesh, like your rendering process does not require normals, you do not no longer need to have things like normals in your mesh. So you can just not have them, and obviously Bevy's built-in shaders won't work necessarily, but your shader may not need that, allowing for smaller files and resource footprints. Expose multi-draw indirect. This is talking about how WGPU has opt-in support for multi-draw indirect, which I don't actually know what that is, but it's an it says it's platform-specific sort of thing, and it allows for GPU-driven rendering, which I guess Bevy doesn't have at the moment, but intends to implement. There's also been addition of the KTX2 array Cubemap array textures. This allows Bevy to do skyboxes, which it says about. It's not implemented yet, but allows for it to happen in the future. So maybe 1.10 will have skyboxes, but you can now at least make them yourself. Bevy just doesn't provide it. Cameras now have a viewpoint to world function. This allows for you to take in a transform and a cursor position and cast a ray, which you can then, say, use in your physics engine. How here it says origin and direction, and this is just about generating an array on the screen from the camera to allow for like world picking and stuff like this. And again, you still, I believe, need to implement the physics system yourself, like it says here. Then can be fed into the Bevy Repair plugin, but this does mean that you do not need to calculate this yourself, and generating rays is significantly easier. They added multi-directional lights, which just basically means you can have 2 spotlights or 3 spotlights in a world, and they will cast independent shadows. I'm assuming the shadows blend correctly. I haven't actually tested this. And it says that limit is now 10, but this does open the way for the same that they did with point lights, that in the future it will allow infinite on platforms that support storage buffers, as opposed to, at the moment, they've got a fixed size buffer of 10. Sprites now have a rect function, which allows you to basically trim out a section of a sprite. This works the same as a texture atlas used to do, or still does, I guess, but on an individual texture as opposed to needing an atlas thing. So you could, in theory, make an animation system that moves where this rect is on a single sprite, as opposed to using a sprite sheet. Plugins now have settings that are hard-coded when you insert the plugin, because they say about it was confusing because a lot of the plugins would take in start time resources that were once initialized no longer used, and would give people the false impression that they could change things such as the window descriptor after the game had started, when in reality you could only change these things at startup. And they've also moved the asset plugins watch for changes. Instead of applying that directly to the asset server, you apply it at startup, which means that this is no longer done when you run the game, so you no longer need to make a system to specifically enable this feature. And this means that a lot of configuration things that are hard-coded are all moved into plugins, and reducing the bloat in resources that are purely needed to be inserted at a specific time, such as like the window descriptor needed to be inserted before the default plugins, because otherwise the default plugins would just assume you hadn't done one and use the defaults. Plugins are now unique by default, meaning that if you try and insert 2 plugins at the same time, or 2 plugins of the same type, they will cause an error and the game will not start. You can make plugins not unique. This will allow to multiple of the same plugin to be added, which you may do is say if your plugin automatically checks to see if resources exist. But this will mean that it's much easier to detect when adding one system or one plugin has already added another plugin, so you don't accidentally add it conflicting plugins, such as the Bevy Editor Please adds the diagnostics and the EGUI plugins. And if you were trying to insert that with the Bevy console, it would cause an issue because it inserts twice and then neither of the plugins work. So you had to insert the plugins in a specific order. The is unique will at least allow you to detect this functionality when you're running, so you don't run into these issues. The task pools can now have spawn nested scopes. This, I believe, just is about like you can scope and then scope inside, allowing for more easily nested pools of tasks. I don't really know what it does, but it says it's about migrating to the seamless RFC, which is the scheduler that I guess won't have more parallelization. The task pool now implements a panic handling. So originally Bevy said that it couldn't do this because it would require every task pool to use the catch unwind, otherwise the panics would be unrecoverable, but now it resolves this by calling catch unwind inside the task pool executors. Hierarchy now has some query methods which significantly improve the usability of, say, children and parents. So children now has an iterate descendants when you use the query that is just children, and a query of just parents also has iterate ancestors, which does the same thing but in reverse, allowing you to descend all children or ascend all ancestors of a specific entity. The origin is now in the top left as opposed to the bottom right. This is to be more in line with the standards of the industry, and also because when you're trying to reason about UI, a lot of the time your UI will grow from the top down, as in almost every experience humans have. We scroll down to go further into the future, as opposed to scrolling up, which means that building the UI from the bottom up was unintuitive. Bevy UI now has Z indexing, which allows you to specify that a specific UI element should be placed above or below another element. Originally, Bevy just used the hierarchy to do this, but now it has a local and a global Z indexing. The local Z indexing will index it amongst its children. By default, they're all 0 and will default back to the order in the children as the hierarchy. But if you set, say, 1 to 1, it will be above everything, regardless where it is in the hierarchy. And if you set it to -1, it'll be below everything. And obviously, higher numbers will move it more in said direction. Global does the same, but ignores the parent. So instead of just being ordered among its siblings, it gets ordered among everything in the entire scene. As an example here, we can make the blue one go behind by giving it an index of -1. And if we change that to a global instead of local, it goes behind its green parent as well. Bevy now has UI scaling, which allows for UI to be scaled uniformly by inserting the UI scaling resource. This is useful for if you have a game that needs its UI scaled, and saves you having to implement this kind of functionality yourself. The playback now has a toggle, so instead of having to check is paused and then changing to play, it will toggle between the two without needing to check. There has also been a functionality of start added, which I might be mentioned later, but I remember it in the changelogs. And start will make it always start from the beginning, whereas play will continue from where it was paused. So this may be for animations, I've forgotten. Time scaling is now a thing. You can set relative time. This will allow you to speed up and slow down animations, and will be useful for if you were saying making a real-time game or a game that has different speeds. You could speed up and slow down the delta time, and then for things like your UI, still use the raw delta time, allowing for animations and that to be sped up and slowed down without affecting things that the user interacts with. Time wrapping is used for instances where things such as shaders will need time to be precise and won't want floating point errors to interact, and may not care if time wraps on large scales, but need to keep track of time on smaller scales. So for example, you can set time wrapping period to 1 hour by saying 60 times 60 seconds, and this will mean that after 1 hour, time will act as if it was to start again. And if you think about it, in most cases, if things in your game after 1 hour loop back to being the start, it's not really that big of an issue, because in most cases you're just looking for the difference between time, not necessarily total time elapsed. So that's everything that was added in this update of Bevy. And next they are adding more post-processing stack, more post-processing effects, asset pre-processing, which will be things like loading assets into a format and basically lengthening development time, but decreasing time spent once you've actually made the app released, so they will load faster and be smaller to release. Bevy UI improvements, more scene improvements. Hopefully, they're working on the Bevy's editor. Oh, I just clicked something. The Bevy editor, which at the moment you can still use the Bevy editor, please, but they will hopefully have an in-house editor coming soon. And the seamless ECS, which a lot of these functionalities they've added where it has the caveat of they're not yet implemented, is currently going to be, is like working towards adding the seamless RC. They're also apparently looking for people who are good in animation and audio, so if you are interested, do jump over to Bevy and lend your support. Thank you for watching. Like, comment, subscribe. I will be putting up a migration guide, basically going through the Bevy's migration 0.8 to 0.9 in the next couple of days. So if you're interested in that, like, comment, subscribe, and I'll see you then.